अच्छा ये हम start अच्छा चलिए ये हम start कर लेते हैं. We were doing naming of organic compounds. जिसके अंदर we had just a second. अच्छा, so we had talked about many things. Alkanes की हमने naming की थी. Alkanes were saturated hydrocarbons. That meant that they only had single bonds. So we did the naming of अच्छा, so we did the naming of alkanes. So alkanes had only single bonds. They were just carbon and hydrogen atoms, and all of them were single bonds, all of them. And that is what an alkane was, saturated molecules. So after that, the way they were named was that what you did was the names are based on two things. One is the prefix, which is the number of carbon atoms. And in your course, in your syllabus, you're only supposed to name simple straight chain molecules where the carbon atoms are all present in a single line. So, so 4 carbon atoms, that would be 4 carbon atoms as but. That's the starting name, and the suffix is going to be ane. 5 carbon atoms, that's pent, and the suffix would be ane. So this is how you're going to name one carbon atom, that's meth, according to this list over here, and the suffix is going to be ane. Hex, 6 carbon atoms, that's going to be hex, and followed by ane. So this is hexane. In alkenes, you pretty much follow the same rule, except that alkenes are not saturated. What alkenes are hydrocarbons. They contain only carbon and hydrogen atoms. That's one thing. And then when it comes to alkenes, the other thing is that there is going to be at least one double bond somewhere. So you draw a bunch of atoms. When you draw those atoms, carbon and hydrogen atoms, there would be at least one double bond. So if I draw an alkene and I draw a bunch of carbon atoms all connected to each other, then there's going to be at least one double bond somewhere. So you need to put that double bond somewhere. And you can add the hydrogens. This one will have 2 hydrogens. This one over here will have no hydrogens. This one will have 3 hydrogens. Each carbon atom should make 4 bonds. So this one has will have 3 hydrogens. So that's what an alkene is. And the general formula of an alkene was CnH2n, which means that whatever is the number of carbon atoms, the number of hydrogen atoms is going to be twice the amount. So if there are 5 carbon atoms in a molecule, the number of hydrogens are going to be 10. So it's going to be C5. And the number of hydrogen atoms is going to be double that amount. It's going to be 10. So that's how you name alkanes. Alkenes are named in the same way, prefix followed by ene. So we were doing this ethene, propene, 3 carbon atoms, an alkene, that's a propene. Now, when it comes to 4 carbon atoms, for example, if I want to draw butene, then I'll have a couple of options, which is that when you have 4 carbon atoms all arranged in a straight line, where do you put the double bond? The double bond could be on the first 2 carbon atoms. And you can add in all the hydrogens. This one, the 4th bond, this is the 3rd and the 4th bond. This is the 2nd, 3rd, and 4th bond. So every carbon atom must make 4 hydrogens. So that is one option, that the carbon atoms, the double bond is on the first one. Or what you could also have is that you can have 4 carbon atoms, and the double bond could be on somewhere in the middle. And you can add in all the hydrogens. This one will have 3 hydrogens. This one is going to have 1 hydrogen. This one will have 1 hydrogen as well. This one will have 3 hydrogen atoms. So this one is also a butene molecule. So which one is butene? Like I mean, how do you differentiate? Because they're both structurally different. There could be a third version that I put the double bond on the last one, but that one and this one is going to be exactly the same. Like there's no point putting the double bond on the last one because I told you rotated, flipped, twisted versions are exactly the same thing. So, I mean, if you look at this molecule, this one will have 2 hydrogens. This one will have 1 hydrogen. This one will have 2 hydrogens. So if you look at these 2 molecules, double bond at the first one and double bond at the last one, they're both exactly the same molecules. They're just flipped around versions of each other. Like if I take this molecule and I start rotating it, what you'll notice is they both now look exactly the same. I didn't do anything except that I rotated it. It's 4 carbon atoms, double bond being at the last one. So remember the first position. So first position and the last position are exactly the same. So this one is not a butene molecule. It's not butene. So we're going to remove that. So anyways, you've got 2 options. Saneem, is this clear? Hamza, clear? Saad, is this clear?
Yes, sir.
So you've got 2 options. So how do you differentiate between them? How do you name them? So you add another thing. When you're naming alkenes, you have the prefix and you have the suffix. You add another thing in the name, and that is in the middle over here, you add the position of the double bond. Like at what position is the double bond? That position has to be added. So for example, this one is bute, 4 carbon atoms. Ene, it's an alkene, but you're going to add 1 to it. That would indicate that this is bute 1-ene. Why? Because the double bond is at position number, it's on the first carbon atom. And over here, the double bond is at the second carbon atom. So this one is going to be called bute 2-ene. And also remember the position or the counting is done from the side that gives the smaller number. From side which is going to give us the smaller number. So this one is our butene molecule. Pentene can be, you'll have the same exact scenario. Like if you draw pentene, so it's going to have the same issue. That there would be many different versions of pentene. Like where do you put the double bond? So there would be, so pent means 5 carbon atoms. So the double bond could be at the first carbon atom, or there could be other versions of this. You could have 5 carbon atoms. And the double bond is at between the second and the third carbon atom. And that's it. All the other versions are going to be just flipped or rotated versions of the same thing. For example, if I put the double bond at the third carbon atom, then these two are this one and this one are exactly the same. Like if I pick this up and I just rotate it around, it's exactly the same thing. So it's just a flipped around version of the same thing. So these two are exactly the same. So I'm not going to draw any more versions, and I can add in the hydrogens. So what I can do is, I mean, this time I'm going to use the compressed notation. This carbon should have how many bonds it should have. I mean, this particular carbon atom, it should have 2 more bonds with hydrogen. So I'm just going to write CH2. This one is already making 3 bonds, so it should have just 1 H. This one is making 2 bonds, it should have 2 H's. This one should have 2 H's, and this one should have 3 H's. And the same thing I can do over here. The first one is only making 1 bond, so I'm going to add 3 hydrogens with it. This one should have 1 H. This one should have 1 H as well. This one should have 2 H's, and this one should have 3 H's. And I'm going to try and name both of them. So if I name the first one, that's pent, and the position is 1. And the second one is going to be pent, and the position is 2. The double bond is at position number 2. If you count from the left side. Okay, Hamza, is this clear? Saneem, is this clear? Just a second. Chalo. Nawal, can you hear me?
Yes, sir.
Achha, have you done organic in school?
We're doing it right now.
I'll just quickly give you a quick recap. We just started it, okay? And after this, we're going to start from scratch, okay? So just a second. I'll just give you a very quick recap. We're just at the beginning. So I'll share the board link with you. So what's organic chemistry? It's a chemistry of carbon compounds, okay? Why are carbon compounds important? Because carbon makes a lot of bonds, 4 bonds. It's in group 4, it makes 4 bonds. It's very useful in making kind of complex structures, really complex structures. And the most complex structures are living organisms. So most living organisms, humans, animals, plants, etc., they're all bacteria, viruses, they're all made from carbon. So when you talk about organic chemistry, you're basically talking about the chemistry of carbon compounds. And you should know which atom makes. So the first thing is you should know how to make proper structures. So the very first thing is you should know that any atom in group 4 makes 4 bonds. Any atom in group 5, it has 5 valence electrons. It needs 3 electrons, so it makes 3 bonds. Anyone in group 6 needs 2 electrons to complete its outer shell, so it makes 2 bonds. And group 7 atoms, they make 1 bond each. So the first thing is when it comes to organic chemistry is you need to learn to know how to draw proper structures, which is that every carbon atom should be making 4 bonds. When you draw a structure, TK, we'll practice that as we go on. Every carbon atom should be making 4 bonds because it's in group 4. So you can count, there's a double bond, 1 over here, 1 over here. This carbon atom is also making 4 bonds, double bond, single bond, that's 4 bonds. This one is also making 4 bonds, this one. So everyone, I mean, even this one, this carbon atom over here should be making 4 bonds. So whenever you draw an organic structure, it should be the correct version. Every atom should be making the right number of bonds. Nitrogen over here should be making, it's in group 5. So that it should be making 3 bonds. So whenever you see nitrogen, it should be making 3 bonds, which it is over here. This one is also making 3 bonds. Whenever you see oxygen, so oxygen should be making, it's group 6, it should be making 2 bonds. So any oxygen that you meet, it should be making 2 bonds, whether it's a double bond or whether it's a double bond or a single bond, that's not the issue, but it should be making 2 bonds. So you have further examples. You can see oxygen everywhere making 2 bonds. So that's what we were up to. So we had started naming alcohols now. So you've got lots and lots of organic compounds, and there are infinite number of organic compounds. Just in the human body, there are so many cells, enzymes, particles, etc., that are all organic. So there are infinite number of organic compounds in nature, and they need to be classified so that you can figure out the properties of a substance. just like animals are classified. The reason you need a classification system is that by just looking at the name of the compound, you should be able to figure out what their properties are. So just like the animal kingdom, like why do you classify things into birds? Because birds have certain properties. So if somebody uses the word bird, you would know that you're talking about a specific thing that lays eggs, etc. It's got these properties. So that's why you classify them into different families. And you should remember this. How is the classification system working, and what is the name given to the classification system? That's a homologous series, which is basically, it's a family of organic compounds which have similar chemical properties. So if molecules have similar chemical properties, you put them in the same family. They show trends in physical properties. So the melting points are low. They would not be identical, but there would be trends in their physical properties. They would have the same functional group, which basically means that organic molecules are large and complicated. So it's whenever there's a chemical reaction, the whole thing is usually not taking part in the reaction. It's a bunch of atoms or a particular structure in the molecule that actually takes part in the reaction. So it's a structure or a group of atoms in a molecule that determines its chemical and sometimes its physical properties as well. They have the same general formula, and so this is what we are working on. I'll just go through and we can start discussing at the moment the third homologous series, which is alcohols. As the first thing, which organic compounds are alcohols? Alcohols are compounds that have specifically this functional group. They have an OH, ON and H functional group. That's what an alcohol is. And obviously there's going to be a carbon chain attached to an OH functional group. So all organic molecules have this backbone. They've got this carbon hydrogen chain, which is known as the alkyl chain. So whenever you see an organic molecule, you'll see lots of carbon atoms, lots of hydrogen atoms. That's your alkyl chain. So every alcohol is going to have this OH functional group. So I'm going to draw a bunch of alcohols first. Remember, the structures need to be correct. So here's a bunch of carbon atoms. I'm going to connect them with a bunch of hydrogen atoms. But there's got to be an OH group that needs to be part of this structure. Remember, this oxygen over here makes 2 bonds. Carbon should be making 4 bonds, so I'm going to add in 2 hydrogens. This carbon is also going to make 4 bonds. This is the third and the fourth bond of this carbon atom, and this one should make 3 more bonds. So that is what a structure of an alcohol would look like. So that's one version of this. So any carbon and hydrogen chain, alkyl chain connected to an OH group, that is an alcohol. Hamza, clear? Salim, is this clear? Saad? And Nawal, is this clear?
Yes, sir.
So I'm going to do a couple of more structures. So I've got this other molecule, and it's got 3 carbon atoms, and I'm going to put the OH over here. Now remember one thing that people make a mistake is that, remember, the H atom is always on the outside because H only makes 1 bond. So it's always at the ends. So when you connect this OH to anything, it's the O that's going to be connected because O is the one that makes 2 bonds. So if I'm going to connect an OH over here, I'm going to connect the O over here. So just 1 minute, Azan ho jaye. I should say this one. You've got this molecule over here. Again, remember I've drawn the correct structure. Carbon is making 4 bonds. This carbon, every carbon atom must be making 4 bonds. And I've attached a molecule can have multiple OH groups. So this one has an OH attached to this carbon atom. There's another OH. And remember, it's the oxygen that should be bonded to the carbon atom. So that is another alcohol. So molecules can have at least one OH functional group. So any molecule, if you see and it's got an OH group and only the OH group, that is an alcohol. ठीक है, ये clear है? Nawal, is this clear? Hamza, Saneem, is this clear? उसके आगे ये कि there's a general formula of alcohols, and that general formula is it's CnH2n plus 1 OH. That's your general formula. That general formula is for the simplest alcohol. And remember, N is usually the number of carbon atoms. So for example, if I take that general formula and apply it to this molecule, now look at this molecule, it's N is the number of carbon atoms. So Cn, H2n plus 1 OH. So if I, what is the value of N? N is the number of carbon atoms. That's 1, 2, 3, and 4. So over here, the value of N is 4. So H is going to be, if I calculate H this way, so H is going to come out to be 4 into 2 is 8, and 8. So 4 into 2 is 8, 8 plus 1 is 9. So it's going to be C4H9 and OH. So the general formula helps us in giving out, without drawing the structure, it will tell us the molecular formula. Now remember, the drawback of a molecular formula is that it doesn't give you the information about how the atoms are bonded to each other. It just tells you the total number of atoms and gives you the functional group that is present in the molecule. So there's one drawback to writing molecular formulas or using general formulas. You can't really figure out the structure. But anyways, there are 4 carbon atoms, 9 hydrogens. That's 1, 2, 3, 4, 5, 6, 7, 8, 9. And there's 1 OH group. So this exactly represents this. Yes.
Can you send the board link?
ठीक है, मैं भेज रहा हूँ, एक second. अच्छा, फिर इसके ऊपर भी अप्लाई कर लेते हैं जनरल फॉर्मूला, which is this one. You've got, if I apply it over here, it's how many? C4H9OH. Sorry, not C4H9, CnH2n plus 1. So if I apply this over here, there are 4 carbon atoms. So this would exactly be C4H9OH. It's going to have exactly the same formula. So 9 hydrogens, you can count that, 4 carbons and 1 OH. So it's going to be exactly the same. But general formulas often don't work when you have multiple OH groups. So it's not going to work if you have multiple OH groups. It's only going to work for simple alcohols. Now the next part is I'm going to draw the condensed versions of the molecules as well. So this is the displayed function version of the molecule where you show every single bonds. So I'm just going to draw a couple of condensed version. Now, the only difference between showing every bond and showing a condensed version is this, that you don't show the bonds over here. For example, if I have this molecule and OH, so completing all the bonds, that's going to be 3 hydrogens. Now, if you look at this molecule over here, and I'm going to draw the condensed version now. So the first carbon atom is attached to, okay, there are 4 carbon atoms. Let me draw those 4 carbon atoms. The first carbon atom is attached to 3 hydrogens. The second one is attached to 2 hydrogens. This one is attached to 2 hydrogens as well. And this last one is attached to 2 hydrogens, and it's got an OH group attached as well. So that's your condensed version. We can even remove the bonds that are in between and So it's basically CH3, CH2, then another CH2, then another CH2, and then your OH. So that's your condensed version, or the formula of for the same molecule. And let's draw the condensed version of another one, which is let's have this molecule, and the OH is so OH is over here. So how do I write the condensed version for this one? It's so this one is 4 carbon atoms again. The first carbon atom is C with 3 H's. The second carbon atom is C with 2 H's. The third carbon atom is C with 1 H and 1 OH. Now, when the OH is written in the middle, put a bracket around it. This carbon atom over here is CH and 1 OH. So put a bracket around it so it kind of differentiates from the rest, that there is C with 1 H and 1 OH. And the last carbon atom is C with 3 H's. So that is going to be your condensed version of the molecule. You can either show bonds between them. So that's your condensed version, or you can simply just keep them all together. That is going to be CH3, CH2, CHOH bracket, and CH3. So those are your condensed version. You should be good with both of them, drawing both of them. Now, moving towards naming, how do you name? Now, remember, for you, naming is simple, just simple, straight chain. I mean, you won't be asked to name complicated molecules which are large and which have these branches coming out and which have multiple OH groups. For you, the naming is just limited to carbon atoms in a straight line. That's it. But these molecules are going to come into your exam, but you wouldn't be asked to name them. You'll be asked to identify them, that it's an alcohol, so it's obviously an alcohol. You'll be asked to do reactions for them, but not name them. Naming is just limited to carbon atoms, all arranged in a straight line. So let's start naming them. So the naming is going to be in 2 parts, 3 parts actually. The first one is going to be your prefix. So that part is your meth, eth, prop, bute, pent, and hex. So pent and hex. So that's your prefix. So those are the number of carbon atoms. So molecule has 3 carbon atoms, that's going to be prop, 4 carbon atoms, that's going to be bute. And you'll have your suffix, which is going to be all. So there's going to be a suffix, and that suffix is going to be all. So everything would end with all if it's an alcohol. And then there is a middle part. That middle part is AN, or so, I mean, it's going to be AN if it's saturated. Saturated meaning that all the bonds between carbon atoms are single bonds, like an alkane. So these are saturated alcohols, like all carbon atom bonds are all single bonds. And it will turn into an EN if alkenes had EN in them. So if this was unsaturated. So I'll even write this down. Saturated meaning that carbon and carbon would have a single bond. And if EN comes in the name, that means that indicates that the carbon and carbon have a double bond somewhere. So I'm going to try and name the easy ones first. So for example, this one, that's 4 carbon atoms. So 4 carbon atoms would be bute. So this name would start with bute. And it will end with all. What's going to come in the middle? AN or EN? Since it is saturated, all the bonds are single bonds, so you're going to call it AN. So it's butanol. That is what the name is going to be. And then there's an additional thing, especially with the suffix. And that additional thing is that both of these are butanols. I mean, this one is also a butanol. It's 4 carbon atoms, so that's but. The suffix is ol. So that one is also an alcohol. So this one over here is but. It's saturated, so it's AN. And it's also an alcohol, so it's all butanol. So the problem is both of them are butanols, but both of their structures are kind of different. So what do you do now? So this was also the issue with alkenes. And this is the same issue with alcohols as well. That this one is a butanol molecule. This one is also a butanol molecule. So before the ol, you do one thing, and that is you add the position of the functional group. So this one, the position needs to be mentioned. Like, where is the OH? On which carbon atom is the OH located? So for example, this one, the OH, and remember, counting is done from the side that gives the smaller number. So this first one, the OH is located at carbon number 1. I mean, this is 1, this is 2, this is 3, and this is 4. So counting is done from the carbon atom closest to it, or the end that is closest to it. Similarly, this one, you're going to count from this end. It's going to be 1, 2, 3, and 4. So counting is done from the side that gives the smaller number. So this one is butan 1-ol because the OH is attached at position number 1. And this one over here is going to be butan 2-ol because the OH is attached at position number 2. So it's the same with alkenes. In alkenes, you had, when you're doing alkenes, you had kind of the same issue. And the issue usually comes at, you had 4 carbon atoms, butene. So the double bond was at position number 1. So it became but-1-ene. You had 4 carbon atoms and there was a double bond in the middle now. And the carbon atom, so it started at position number 2. So but-2-ene. So in alcohols, every time you're going to give the position of the functional group. So I got butan 1-ol and I got butan 2-ol. And similarly, let's try another one. ये सारा clear है?
Yes.
Achha, so similarly, we can do another one, which is 3 carbon atom. I've got an OH over here. And we can add in all the hydrogens. So this one will have 3 hydrogens. This one will have 2 hydrogens. And this one will have 2 hydrogens as well. And I'm going to do another one, which is 3 carbon atoms. Okay, OH is attached at this position. And remember to connect the O, not the H. OH. This one will have 3 hydrogens. This one will have 3 hydrogens. And this one over here will have just 1 hydrogen. So I'm going to try and name them. Both of them have 3 carbon atoms. So this one is prop. And it is saturated because all of them are single bond. So it's propanol. And this one is also prop, saturated. So that means it's AN, all single bonds, and propanol. Except that this one is position number 1. Okay, counting is done from the end that is closest to it. So this one is propan 1-ol. And this one over here is, you're going to count from the side that gives the smaller number. So it's 1. It's on the second one. So it's propan 2-ol. So that's how you're going to name alcohols. If I draw another one, let's say pentane 3-ol. So how would this molecule look like? Pent over here means 5 carbon atoms. So that means there are 5 carbon atoms that are in a line. So I've got 1. So that's 1, 2, 3, 4, and 5. All means it's an alcohol. So there's an OH group and it's located at position number 3. So it's on the 3rd carbon atom. That's where the OH is located. Now you can decide to make all the bonds or just right condense. This would have 3 hydrogens. This one will have 2 hydrogens. It's already making 3 bonds. So this one should have just 1 H. This one should have 2 H's and this one should have 3 hydrogen atoms. Okay, so that's your pentane 3-ol molecule. So just remember, naming is just limited to very simple molecules. Okay, you're not going to be asked to name like complicated molecules like this, where you have lots of branches happening, multiple functional groups. You wouldn't be asked to name them, but they will come in your exams, except you wouldn't be asked to name them. But otherwise, you should know what is an alcohol. And I'll do just one other example of an unsaturated alcohol. What if there's a double bond? So let's do one with a double bond. So when you have a double bond, same thing, it's 3 carbon atoms, that's prop. And it's an alcohol, so it's obviously all, the position of the alcohol group is 1. So the double bond is at position number 1. So it's 1-ol. And instead of the AN, it's going to be EN. That is the only difference. So instead of propanol, it's going to be propenol. Instead of the AN, because of the double bond, the EN represents carbon and carbon double bonds. ठीक है, is this clear? You clear, Hamza, Saneem, Saad, Nawal, is this clear?
Yes.
चलो ठीक है, let's continue in the next class then, ठीक है? Okay, then take care.
Awesome.
Allah Hafiz.